A ball is thrown vertically upward with an initial velocity of 96 feet per second. The distance the ball is from the ground is given by d of t, where d of t is the distance in feet and t is time in seconds. For part A, at what time does the ball hit the ground? Well, the ball hits the ground when d of t is equal to 0. Let's first take a look at this graphically. D of t is equal to 0 along the horizontal axis. So notice how d of t is equal to 0 at t equals 0, as well as at t equals 6 seconds. Well, t equals 0 is when the ball is thrown upward, and therefore the ball hits the ground after 6 seconds. To answer this question algebraically, we set d of t equal to 0 and solve for t. So let's also do this. If we set d of t equal to 0, we have the equation 0 equals 96t minus 16t squared. To factor the right side, we factor out the greatest common factor, which is 16t. If we factor out 16t, we get 16t times the quantity 6 minus t. The product on the right is equal to 0 when 16t is equal to 0, or when 6 minus t is equal to 0. Solving for t here, we divide both sides by 16. Simplifying, we get t equals 0. Solving for t here, we add t to both sides, which gives us 6 equals t, or if we want t equals 6. So again, t equals 0 is when the ball is thrown upward, and t equals 6 is when the ball hits the ground. So the ball hits the ground after 6 seconds. For part B, when is the ball more than 128 feet above the ground? The ball is more than 128 feet above the ground when d of t is greater than 128, and since d of t is equal to 96t minus 16t squared, to answer the question, we need to solve the quadratic inequality 96t minus 16t squared greater than 128. But let's first take a look at this graphically. If we graph the function d of t, and then graph d of t equals 128, which is graphed in red, notice how the blue graph is above d of t equals 128 here, when t is between 2 seconds and 4 seconds. And we do not include t equals 2 and t equals 4 because that's when the distance is exactly 128 feet, and we only want to know when it's greater than 128 feet. But again, let's also solve this algebraically. Let's first set this equal to 0 by subtracting 128 on both sides, and also write the terms in descending order. Let's write this as negative 16t squared plus 96t. Then if we subtract 128 on both sides, we have minus 128 greater than 0. The first step in solving a quadratic inequality is to solve the related equation, which in this case is negative 16t squared plus 96t minus 128 equals 0. The greatest common factor on the left is 16, but let's factor out negative 16 so that the t squared term is positive. If we factor negative 16 from the left, we have negative 16 times the quantity t squared minus 6t plus 8. And this does factor further. T squared is equal to t times t. The factors of positive 8 that add to negative 6 are negative 2 and negative 4. So we have t minus 2 and t minus 4. T minus 2 is equal to 0 when t equals 2. Or t minus 4 is equal to 0 when t equals 4. So these are the values of t where the height is exactly 128 feet, and therefore we don't include these values of t in the solution, and therefore we plot them as open points on the number line. And now we test each interval to see which intervals are true. On the left, let's test t equals 1. Let's use this inequality here so that we can compare it to 0. If we substitute 1 for t, we have negative 16 times the square of 1 plus 96 times 1 minus 128 greater than 0. The left side simplifies to negative 48, which is not greater than 0, and therefore this entire interval is false. And now let's test t equals 3 for the interval in the middle. For t equals 3, we have negative 16 times the square of 3 plus 96 times 3 minus 128 greater than 0. The left side simplifies to positive 16. Positive 16 is greater than 0. This interval is true. And now let's test the interval on the right. Let's test t equals 5. For t equals 5, we have negative 16 times 5 squared plus 96 times 5 minus 128 greater than 0. The left side simplifies to negative 48 again. Negative 48 is not greater than 0, and therefore this interval is false. So the interval that is true is the interval in the middle, which is our solution. The solution is the interval from 2 to 4, not including the endpoints. As interval notation, we have the interval from 2 to 4. Because we don't include the endpoints, we use parentheses. Or as a compound inequality, we have t is less than 4 and greater than 2. Let's also state the solution as a sentence. The ball is more than 128 feet above the ground between 2 seconds and 4 seconds. And again, we can verify all this by looking at the graph. The ball is above 128 feet between 2 and 4 seconds, and again the ball hits the ground after 6 seconds. I hope you found this helpful.